All right, let's see if we can answer lesson practice A, B, and C. And I'm also going to make a point about example 4, something important that I'm going to point out that's a shortcoming of what's in there, just in case you go back to example 4 to look for guidance. First of all, I'm going to talk about lesson practice A. Can another plane be drawn that contains points A, B, and C? Justify your answer. For a question like this, where it says justify using a postulate, you have to have your book open to the theorems and postulates that you just learned. And I'm looking through, looking at the postulates. Oh, look, there's postulate 6, which says through any 3 non-collinear points, there exists exactly one plane. So how would I justify? Postulate 6 says that only one plane can be drawn through 3 non-collinear points. And that doesn't, because we accept that postulate 6 is true, then that's our justification for why we would say no. Actually, I forgot to say no. No, there can't be another plane. Postulate 6 says so. All right, what about B? B says to identify a line in plane M. Boy, I could identify all sorts of lines in here. I see that F, E, and O are on the same plane, obviously. So is line AB. That's the intersection between plane M and plane N. So that line is on both of them. So I would say line FE, line EO, line, let's see, BA. That's my favorite one. So I'm just going to write line BA. Uh-oh, I need to make that line notation to make it official. So let me just, over here, I'm going to make one of those double arrow lines. And then we're just going to drag that over so that it's on top of where it should be. Okay, notice I didn't put A and B in alphabetical order. That's okay. It doesn't matter. BA and AB are the same line. All right, let's see. Oh, no, there's more questions. What is the intersection of planes M and N? Oh, guess what the intersection is? It's line BA or line AB. So either one of those could be correct. All right. Hey, can I use the same answer for both of those? I sure can. The line of intersection has to be on both planes. So that means it is a line on plane M. And then it's on plane N as well. Then it asks, are points E and F coplanar? I'm looking at E, looking at F. Now, I don't like this question because E and F are obviously coplanar because they're in the same plane. I wish they would have asked, are points F and, like, let's see, what's one that's on C? I don't know if there's a point drawn at C. Maybe that's why they didn't ask it. But are points F and C coplanar? And the answer would always be yes. 2 points are always coplanar. 2 points are always coplanar. 3 points are always coplanar. Even if they're non-collinear, 3 points are always coplanar. But 2 points are always coplanar. So no matter what, E and F have to be coplanar because they're just 2 points. It takes 4 points to have a set of non-coplanar points. All right, and then finally, C. Often camping supplies are made with 3 legs. For example, chairs, stoves, and small tables often have 3 legs. Explain why they might be made this way and use postulates to explain your reason. Well, we're going to go right back to postulate 6. But before I do that, I just want to point out in the example up above that purports to explain this. They say the legs of a 3-legged table make a single plane as shown in postulate 7. Let me read postulate 7. If 2 planes intersect, then their intersection is a line. Planes M and N intersect at line AB. Wait a second. Postulate 7 talks about intersecting planes. It has nothing to do with 3 points. Could the book be wrong? Could Saxon have made a mistake? Yeah, I think that's what happened. So it should be postulate 6. Postulate 6. So why are they made with 3 legs? 3 legs define a flat plane as postulate 3. Let me fix this. The points at the bottom of 3 legs define a flat plane as postulate 6 states. Okay, so what that means is that my 3 legs are always going to make a plane. If there are 4 legs, then the bottom of one is let's see, could be non-coplanar if not perfectly level, which could lead to a wobble. And nothing is worse than a wobble, let me tell you. All right, so those are the answers to the lesson practice questions. Now you're ready to begin the actual lesson, problems numbers 1 through 30. Be ready for the lesson 4 questions to refer back to the postulates and theorems that you learned in this lesson.